So, a quick aside that I probably should have done at a different point in the course is talking about the fundamental importance of normal distributions, which is that they arise in many situations because the process, anytime you have a process where there's the cumulative effect of many small processes, you get the normal distribution. And that is a consequence of the addition rule because we can add up every different possible path to get to one of these bins, and that is the probability of that path occurring. So there are fewer ways to get to the edges and more ways to get to the middle. So you have this bell-shaped curve. And the exact center of the bell-shaped curve is going to depend on where this hopper goes, and that would be equivalent to the mean. So if it was moved over here, the center would be over here. And how spread out or how narrow things are is going to be a function of how many of these little rows of bouncers that the beads have to go through. And if you had like a very, very deep row, things would be more spread out. So we'd say there was a greater standard deviation. And so because there are many small ways, many small effects, bumping higher or lower, causing a normal distribution, that leads to this other interesting thing, which is that even if you have a variable that is not normally distributed, if you sample some of that data and find its mean, those means will be normally distributed. So, for example, here's a bunch of different asymmetrically distributed things with low values are more common than high values. But if you find the mean of each of these things, they're always going to be, these are random samples drawn from the same distribution, and they all have similar means. In fact, just by chance, most of them are going to be close to the true mean of the population. Some will be extraordinarily low or extraordinarily high, but for the most part, you're going to be centered around the middle. Another way to say that is, each time we look at an observation, there's a small chance it's going to be low or a small chance it's going to be high, and all those things add together to create a normal distribution. So central limit theorem says that means are normally distributed, especially sample means. And that is why the normal distribution is so good for so many things. It's because if you're having trouble with a weirdly distributed variable, if you can convert it into an average, then it will be normally distributed.